Let's try section 10.5, page 528, exercise 14, which reads, determine whether the series converges or diverges. And for exercise 14, the series is the summation from n equals 0 to infinity of e to the n divided by 1 plus e to the 2n. Now there are probably several different ways to solve this, but I want to try this using the integral test. Now the integral test tells us that we let the nth term of our series be equal to some function f of n, and then we're going to take the integral of that function from some positive value capital N to infinity, and if that integral converges, then the series is going to converge from some capital N to infinity. So we're going to let our f of n be equal to our nth term, so that's going to be e to the n over 1 plus e to the 2n. Recall that f must be continuous, positive, and decreasing. And so we're going to allow our capital N to be equal to 0 because our function will be continuous, positive, and decreasing when we are bigger than capital N equals 0. So now we're going to write our integral from 0 to infinity of e to the x over 1 plus e to the 2x dx. And I'm just going to write this a little bit differently. So I'm going to have my integral from 0 to infinity of e to the x over 1 plus e to the x squared dx. And one of the first things that we do when we are trying to evaluate an integral is to ask ourselves if we know the antiderivative. And the answer is that we do in this case, but we might need to make a little u substitution to make it a little more obvious. So we're going to let u be equal to e to the x, and then du is going to be equal to e to the x dx, which means that my integral is going to become the integral from 0 to infinity. I'm not going to worry about the limits at this point. I'll substitute back in for u at the end, and I'll leave my limits in terms of x. And that's going to be du over 1 plus u squared. Do you recognize what this integral is going to be now? Well, you should, and it is actually equal to the arctan, or the inverse tangent, of u, evaluated from 0 to infinity. And if we substitute back in for u, we're going to get the inverse tangent of e to the x from 0 to infinity. But when we go to substitute in our limits, we can't really have e to the infinity. So when I substitute in infinity, I'm really going to make this the limit as k goes to infinity of the arctan of e to the k. But I can just substitute in x equals 0. So that's going to be the inverse tangent of e to the 0, which is equal to 1. And when we evaluate this, we're going to get pi over 2, which you can see if you graph the inverse tangent. And this is going to be pi over 4. So our answer is going to be pi over 4. Now, this means that our integral converges. It has an answer that is a number. And if our integral converges, then our series is going to converge as well.